We have here, first thing, a straight line, equation of a straight line. What's the slope in this case? 0.25. What do we mean by that? It's a rate of change. It's a rate of change. How will it be explained in a straight line case? It's a straight line. Will it ever change the slope for this straight line? It's not going to change. Let's do one thing. I will hold this left arrow key, the left mouse key. I will hold it. When will I hold it? When I have the cursor on the plot. Here, try to plot this with me. On your desk mouse also, plot this line. And how will you do that? Hold this key when your cursor is on the plot, and you see what happened? It shows me the coordinates. Agree? Agreed. This can easily move. When I will move the cursor, I can see what is the value of y when x is -4. Do you see that? 0 for -4. You can do it yourself. Bring your cursor on the line where it intersects the x-axis, and the value over there for x is -4, and for y it's a 0. Now tell me, if I will move the cursor where x is -3, what will be the value of y? If I will move the cursor from 4 to 3, what will be the value of y? 0.25, because that's what we mean by the slope from here, from 3, from 4, when I moved to 3 here. I'm trying to stop at 3, but it's difficult because it's too zoomed out. Now with this level of zoom in, let's try it one more time. When my cursor is at 4 over here, I have exactly 0. And when I will move from 4 to a 3 over here, what's the value? 0.25, exactly. That means with a single unit change in x, the y changes with a single same constant unit of 0.25. And that's what the slope is, rise over run. The change in y due to the change in x. Now let's move one more time from -3. I will move it to a 2. So clearly we have one more change of 0.25, which gives me a 0.5 in total. That never changes. With every single unit change in the x, y will always be changing 0.25. Agreed? Is it something new? Nothing new. You know about that already. Now, let's go for the exponential curve. I'm not bringing in the quadratic at this time because today we are working mainly on exponential. What will happen in the case of exponential? Y equals, let's bring it in. Y equals 2 times, I will use the parentheses over here, and I'm intentionally writing the curve, the exponential curve equation in a different way. I will try to bring in something like this. This formula for the growth and this formula for the decay, I will put it over there on the screen also. I'm trying to bring in something like that. So 1 plus a b. I have intentionally mentioned a b there. And as soon as I will mention the b, you will see there will be a change here. Let's close the equation. And then with that, in the exponent, there should be a variable. Remember, in the exponential function, the variable is also, always in the exponent. What do we need to do next? It's asking me, should I add a slider for the b? Yes, let's do that. And if I will hit this slider, it will bring in the b with the initial value as 1. Do we have the same rate of change over the exponential curve also? Will it remain constant? Oh, what do I mean by that? Let's check the one thing again. If I will check on this curve, the purple one, at -4, what's the value of y? For -4, the value of y is 0 point something, 0.1 something. Yeah, I think this way it will be easier. Yes. So here at 4, 0.125 is the value of y. So if I will move from 4 to 3, let's look at the change. How much will it change? I move from 4 to 3. And what's the value now? Here? 0.25. Okay. How much is the change? 0.125? From 0.125 up till 0.25, the change is 0.125. Now what I will do, we will move it from 3 to 2. And what is the value of y here? How much did it change now? 0.25. And then from 2 to 1, is the change constant here? It keeps on multiplying with the 2. When it keeps on multiplying with the 2, that means the change is not constant. The change is not constant in that case. Then that means the change is not constant. The change is changing. In the lines case, the one that we were looking at first, in that case, yeah, because the scale was no. Okay, next thing. So what I'm trying to bring in here, in the straight line case, the change is constant. It doesn't change at all. But in the exponential case, look at this now. At 0, it is a big change. From 0.125, 0.25, it rose to 2. And at 1, it's another big change. Exponential changes exponentially. Exponential function, whenever it is, it can be the growth of a population, it can be the growth of bacteria in a lab, or it can be the debt on the credit cards. Your parents may use the credit card and they will always be trying to pay off the total amount of the balance on the credit cards like as much as early as possible, as soon as possible. As soon as possible. Okay, why? Because the interest rates are a lot on the credit cards. 30%, 25%, 24% is a big number, and it's compounded. We will now be looking at the compounded interest rate changes in case of the student loans, in case of the cars, in case of many different options. Okay, even the bacteria or the viruses in a lab. For those also, the exponential changes are always multiplicative. Change will not be constant. Change is on an exponential growth or decay. Keep it in mind. Now, I'm going to give you the two formulas that we will be using on this worksheet as well. What two formulas? The first one is for the growth. And the second one is for the decay. And I will mention the formulas over here. Let's do it. First formula for the growth, second one for the decay. I will try to use the same notations for both. So F. Where is it? F stands for the future value. Future value. F is the future value. And what am I writing it? Equal to? This is equal to an A, and then in the parentheses, I will mention something. Let's wait for that. And on the top, I will mention an X. This formula will work for the growth. Whenever we have a growth. Yes. And then we will also work on the decay. Same thing. We will try to figure out the value for the feature in sometime in the future. That's why I'm using the letter F for that value. We will have an initial or the current value, and I'm representing the A as a current value here. Then after that, I will put something over there in the parentheses, and the exponent again is X. Do you think these two formulas are different from each other? So far, same. I will mention here 1 and 1 in both the cases. Even now, it's not different. I will mention a B and a B here for both cases, the decay and the growth. Nothing changed so far. Now is the change, and what is that change? In the case of growth, we will have a plus. In the case of a decay, we will have a minus. Make sense? Only change in these two formulas, which are the exponential changes. Only difference is first is the plus sign, it increases. Second is the minus sign, it decreases. Let's see how will it impact. Here, does it not look like the same thing? This formula, y equals a times 1 plus b raised to power x. This is a growth. Second formula over here, let's try it now over here. Y equals 2 times 1 plus b, and then raised to power x, but instead of a plus, raised to power, it should be in the exponent here. And then here, instead of a plus, I'm going to mention a minus. What will that give us? One thing that I messed up here, y should also be like this, a lowercase y. Do you see it?
It's a line, straight line. So that line is never ending.
Yeah, you're right. It's never ending. I think I did something wrong while typing it in. Let me do it again quickly. What I will do, I will remove it and let me get rid of this straight line also. I just want to bring in here y equals 2 times like this 1 minus a b, and then let's make it exponential with an x. Yeah, it's still a line. Now it will not be aligned when I change the value of b. Make sense?
Oh.
I didn't notice that initially the b was at 1. That was the case. Whenever the b is 1 or a 0, that will be a different. So you look at this. Whenever b is a 0, let me handle it myself. Whenever the b is a 0, what happened? Straight line. That's what was happening actually. Why? Because when we have a 1 there, it will be a straight line. But when the b is something different, you will see the exponential function. For an exponential function, the base should never be 1. Keep it in mind. Here we have a different base. So the green one is exponential growth. It's going upwards. You see the green here, with the change in x, the values are increasing. Y is going up. With the decay, with the increase in x, y is getting smaller and smaller and smaller. These are the two things which are different over here. Now we will go for the example. And what example? In the worksheet. Let's go over there. The student loan here. Let's read it together. Student loan. Here we have it. Let's read the statement together. What's happening? And you may have to face this situation, almost everyone. We may have to face this situation where you will be applying for the loans, and with those student loans, if you're applying it for the college, there are 4 years for the college before you graduate. And normally you will have to pay the fees at the beginning. That means you need the loan in the beginning. At the end of the 4 years, you have not paid anything back. You will keep on utilizing the amount from there. So that means there will be an interest compounded. For how many years? 4 years. That's what is said over here. What is it saying? It's saying in order to pay for college, many students have to take out loans, and that's a fact. If your parents are paying it, good job. You should be a happy face at the end of the 4 years. Otherwise, a loan will already be there. And you need time to pay it off. 1 year, 2 years, depending on the job that you will get after the college. I wish you will be able to pay it as well. Or maybe your parents will be paying it for you. Good choice. Here, what's happening? The same 4 things. The feature value that we are trying to figure out. The basic value at the beginning of the exponential curve, A, that's what we are trying to figure out. What's the growth rate? The B, that's what we are trying to figure out. And how many years of the terms are involved? The 4 things we need from this statement. Let's try to get it. It's telling you in order to pay for a college, many students have to take out the loans. One bank offers student loans at the rate of 2.75%. What is the rate? 2.75%. And don't miss it. There is a critical thing here. It's also telling you compounded. How often? Annually. This is important. Don't miss it. Although we are not using it, but this is a trick. We will learn here how to not to fall into that trap. Now, we have this first information, which is a 2.75. I will call this a B because the formula that we have just mentioned, this is going to serve as a B there. Then after that, how much is the initial value, the face value in the beginning? 8,000. We have the loan amount within 8,000 in the beginning. That's the principal value. I will call that an A in the formula that we have. This is the A because this is at the beginning. Then after that, the bank starts calculating interest on the loan right after they issue the money to you. So when I was reading the statement, I already collected some information. F, do we have it? Feature value? We don't have it. We will look for that. Do we have the B? How much is that? 2.75%. And I would suggest you to keep it in mind that whenever you have something in percentage, that means it's divided by 100. If you want to convert that percentage to decimals, it's divided by 100. What else do we have? Do we have A? 8,000. What's missing? We are missing here the value of F, and that is the feature value. So let's read the next line. It's telling you how much interest will have accrued on the loan after 4 years, after your 4 years of college. So what do you think is this number 4 here? Good. That's the number of years, the number of terms. I will mention that thing as an X in my formula. And then what's the question? It's asking you to find out how much is the interest rate. Not the interest rate, the interest amount that will be accruing on your loan in how long time? How much time? 4 years. So let's bring it here. I will try to figure out what is the F. Thank you. I will try to figure out what's the value for the feature. That amount, that loan, how much will it be in total in 4 years from now? So that's a feature value, F. And how will I do that? A will be replaced with an 8,000 if you have taken the formula already in your notes. A was 8,000, so I replace the A with an 8,000. And then 1, is it a growth or a decay? Growth. Loan will increase. I wish that over the time loan will automatically be decreasing, but it's not happening in the real life. Loan will keep on growing if you're not paying it off. So 1 plus B is the 2.75%. That means I should be mentioning there 2.75 divided by 100 raised to power X. And X here is a 4. How to solve it? To solve it, I will go to Desmos, input the same thing this same way over here, and Desmos will give me the solution. Look at that. 8,000? 8,000 times 8,000 times what? 8,000 times, where is times? Times is here. 1 plus, what's a B? 2.75 divided by 100. And then over here, raised to the power, what? A 4. What did he get? 8,916. 8,916. What is that amount? Huh? You said feature value? Exactly. This one. Okay, and then we can definitely write this value over here. 8,916. It's done. Good. Now, does it make sense? We have calculated the growth. If something is decaying, whatever it is, lead viruses or uranium or with the fusion or something, decay rate, you will put the minus here, but in this case, we are putting a plus. Now, next thing, let's keep on reading. The next thing it's saying is, we have a friend, a very good friend. He or she is trying to help us take a smaller amount of the loan or a smaller interest rate of the loan. What is she saying? Your friend here says, since you expect to be in college for 4 years, and 4 years, and you're being charged for how much? 2.75% every single year. The total you will owe after 4 years, is 11% increase of your original amount. Is she right? Is she or he right? What do you think? Is your friend correct? How much was the interest rate? I know that the feature value was 8,916. What was the interest rate actually? Sorry, not the rate, now interest amount. How much was the interest amount? To find out that, I will definitely subtract from 8,916 and 8,000. And that will give me how much was the interest rate? Oh, sorry, the interest amount. How much is it? Exactly. So the interest amount is 916. 916. Is it 11% of 8,000? How will I know about that? It's easy to calculate the percentage. I will take an 816, divide that with an 8,000, multiply that with 100, and I can simply do it in Desmos over here. Again, in Desmos, 916 divided by the initial amount, 8,000, and then I will multiply that with 100. What will that give me?
Mr. Wagner, hold on.
Tell me.
Can you go back to the other screen?
Sure, I'm here. Tell me.
Where'd you get the A16?
I said 916 and it's written 816. I will change it. What is it actually? Thanks for mentioning that, Jayla. What is it actually? Thanks for the correction. 916. And what have I mentioned over here? Here I'm writing it correct. I was saying it right. I was typing it in Desmos right, but my bad. I put over there 800. Are we good?
Yeah.
How much is it in percentage? 11%, roundabout? So, is my friend or your friend right? Is she right? So it's almost 11%. Now you see, the friend has built up his or her confidence. What is she or he suggesting next? And that's the key point here, you know. The friend is now telling us, because she has already got our confidence, that whatever she is saying or he is saying is right, 11%. Now the next suggestion is, suppose you have the option of choosing a loan from a different bank. Now the things are changing. Will the total amount change that I need for the studies? 8,000, will that change? I need the same amount as a loan. College fee will not change if I'm changing the bank. Agree? The college fee, the total tuition fee will remain the same, and that will be 8,000 again. What else is happening over here? This is a good bank. Seems like a good bank. They are charging me how much? 2% instead of 2.75. This bank is charging me less than 2.75, 2%. But there is a trap here. You know what's a trap? How much was the time in the first bank? How often was it compounded? Annually. And here, what's happening? How many times is it getting compounded? Yes, it's getting compounded every 6 months, and that's where the catch is. It's compounded every 6 months, and I have highlighted it in red. Why? Because how many compoundings will be here in 4 years? Because we are taking the loan for 4 years. We're not going to pay back when we're studying. 8, exactly. So what's the value of x here in that case? In this case, x is 8. What is the value of b in this case? 2%, exactly, 2%. So b here is the 2% or the 2 over 100. The x is 8. What's the a? 8,000. That did not change. Perfectly fine. Now, is it possible for us to find the feature value? What will be the total loan in 4 years from now? How can we do that? Using the formula for f. So f is going to be 8,000 times 1 plus, what's b? 2%. So I will write that as 2 over 100 raised to power 8. And that's the catch. Let's solve this in Desmos. Now back again over here. How will this turn out to be? Let's look at that. This is going to be, let's see, your friend is a good friend or they are trying to like, do something as a mistake. So you want to name your friend at this time? Who can it be? Who's this friend? Bring something that is in mind of a good friend or a bad friend. Let's see who is it or how is the friendship. Raised to power 8. What is that total amount? In 4 years, same time, even with a less rate of interest, the total amount that we owe to the bank is what? 9,373. So is it a good option or a bad option? Bad option. Even the interest rate was lower, but the compounding made the whole difference. Make sense? So you need to be careful. Whenever your friend is suggesting something, it's not always true. Seems true, seems good, that 2%, but many things are there. So be careful. What's the interest amount here? Can you explain it in your own words? What should you do here? How much is the interest amount? 9,374 minus 8,000. This is going to be 1,374, which is way bigger than the 916, which is way bigger than the 916 that you were charged earlier. Make sense? That's how we will be working on your compound interests or compound growth. This formula was for the growth, not for the decay.
Sure. Why you put 74? Yeah.
Yeah, that's a good question. Let's have a look on this. In Desmos, what was the value? 9373.27. You're right. I should not be putting 74. I should be putting 73 because the change is less than 0.5, so decimal value. So this is 73. Thank you.
Can you go back to
That means we are looking carefully, and I like that. Good. Be watchful, huh? Whenever you're working on this. And I think I remember I mentioned if you will catch my mistake, you will get extra credits.
Well, we all did it.
Yeah, we all.
Good. So you will have the extra credit. Today I know that Cameron and Jada will mention one mistake on the board, and then Amaya. Amaya also mentioned.
Yeah,
mistakes
bless
on the board. Keep mentioning if something is wrong on the board, and you will get the credits on that. Got it?
Oh, wait, look,
Yeah,
you can, you can,